Minesweeper is a simple logic puzzle. Each number tells you how many mines surround that tile. So this 1 tells us one of these surrounding tiles is a mine. There is only one surrounding tile, so we know that's a mine. Now using these simple rules, we can slowly begin to make progress. Notice how when you click a blank tile, all the surrounding tiles burst out, because a blank tile means that there are no mines around it. Despite the game appearing simple with its basic rule set, because of the randomness of the puzzle, you can encounter some pretty tricky situations. In this case, once I complete the puzzle, I have won. Now in this video, we are going to be looking at how I coded this and what algorithms are needed. This is the code that generates the random grid of mines. First step is to simply place all the mines down at random positions. My specific Minesweeper implementation places 12 mines at random locations in the 10 by 10 square grid.
This is an example of 12 lines being randomly placed in the grid. As you can see, we just randomly placed 12 lines. The user will not actually see this. This is just an inbuilt representation.
The next thing to do after placing our mines is to generate the numbers that surround the mines. So we just generate all the numbers like this. For each cell, we count how many mines are in the neighboring cells. For each time we spot a mine in a neighboring cell, we increment a certain counter by 1. Now, once we have the number of mines surrounding a cell, we put that specific number in that cell. If there are no mines surrounding the cell, it becomes a blank tile or 0 tile. We do this for every single cell that isn't a mine, and now every single cell other than the mines will have a number. So now every cell will either be a blank tile, 1 tile, 2 tile, 3 tile, 4 tile, 5 tile, 6 tile, 7 tile, 8 tile, or a mine.
Alright, going back to the simple demonstration, all we have to do from here, once we add the numbers, it will look something like this. So as you can see, we have blank tiles when there's no mines surrounding, and when there are mines surrounding, we put the specific number there. As you can see, a lot of tiles are just blank, many ones are there, there's some twos, some threes, and a few fours. And there's a couple of mines. Once we have the mine grid and number grid, the rest is very simple. First, we hide all cells. So every cell will initially look like this, the covered cell. This is how the texture looks like. However, whenever we click on a cell, we uncover the cell and show what is there. If that cell happens to be a mine, it's game over. You lose. If it's not a mine, then we show whatever number is there. However, my Minesweeper has a unique feature where the first click will always be a 0 tile. That's just to give some nice flood fill action. We'll get into what the flood fill is later on. And in order to determine which cell we clicked on, there's basic mouse detection code. You can also flag a cell, which is good in case you accidentally hit it later. I believe the flag cell code is over here. The point is we keep track of the list of uncovered cells and the list of flagged cells to continue the game logic. And once the player is lost, we let them press R to generate a whole new thing. everything reloads at 60 frames per second. The only piece of logic we have left to discuss is the flood fill logic, which happens whenever you hit a 0 tile, which is guaranteed on your first click in my implementation. Flood fill logic is basically how, when we hit a 0 tile, the game auto-uncovers all these other tiles. If any of those is also a 0, we do the same thing, uncovering all neighboring tiles. And this can keep going in a massive chain reaction. The code that does this is called a flood fill algorithm. The flood fill logic starts here. When we click on a tile, we uncover the cell, as long as it's not already been uncovered or it's a flagged tile. Now, if we go to the uncover cell function, as you can see, it simply adds this to the new list of uncovered cells. However, notice how it says if cell value is not 0, we do this in return. Since if it's not 0, it would have exited here, we assume that if it's still here, it's a 0 tile. And if and only if it's a 0 tile, we run the flood fill command function. Over here, as you can see, it's just using a queue. I was going to use recursion for this, I just couldn't figure out how to get it to work, so basically whenever I try to use recursion, it would keep going into an infinite recursion error. So I simply used a queue instead. When I first did this, it wasn't using a queue, but then I figured out queue would be faster. So the idea is we make a queue for all the cells that we need to extend to. And the idea is for all cells that haven't already been added to the queue and extended into, we just add them. Queue is like a linked list. It's good because here we often have, we're often appending cells and getting rid of stuff at the front. And linked lists and queues are good for getting rid of the first element very quickly. So that's how I made Minesweeper in Python. Like at the start of this video, I'll be playing another game, but this time I'll be explaining how the code does everything right now. Now already, before I even did anything, it generated a mine grid and number grid. So internally, it's already known where all the mines are. However, graphically, everything's displayed as uncovered because there have been no uncovered cells in that uncovered cells array. The first click is guaranteed to be a 0. Basically, it figures out where I first click and it keeps generating grids until it gets a 0 in the place where I click. Already, that huge chain reaction flood fill action goes on. More than half the grid is already uncovered. Now, as you can see, I'll use basic Minesweeper logic to determine that these are all mines, and so on. Notice how I'm using the flag function. Every time I uncover a cell here, it's adding that to the list of uncovered cells and displaying it. Every time I flag a cell, it's adding it to the list of flagged cells and displaying a flag there. If I click on these, it doesn't do anything because it's flagged. That's just to prevent against accidental misclicks. Now I can keep going here. As you can see, the flood fill action happening. I click this cell. It opened this cell, which opened all of these. Another flood fill. Actually, no flood fill this time. I simply put 1 0 and it opened these three. That's the simple 0 tile action. And I won this time, unlike the start where I actually, I think I won in the start as well. I hope you enjoyed this video. Thanks for watching and see you next time.